Hi students, coming to the next topic in the subject operating system is fixed partitioning. So in the previous video I explained about some memory management techniques. So the memory management technique may be uniprogramming and multiprogramming. So you can done the memory management in uniprogramming or multiprogramming. So the multiprogramming memory management, a multiprogramming memory management again is divided into two types. It may be a contiguous memory location or non-contiguous memory location. Okay, so the multi-programming memory management is maybe a contiguous or non-contiguous memory location. So in the contiguous memory location, the memory can be allocated contiguously in the form of fixed partition by using fixed partition or dynamic partition. So now we will discuss about this contiguous memory location. This is a contiguous memory location. So in that we will discuss about the fixed partition. So what is this fixed partitioning? A fixed partitioning here, everything, whatever the partitioning that we are doing by using the memory management techniques, that will be done in the main memory. The main memory is divided into number of static partitions. So we call it as a static. The fixed partition is also called as a static partition. Static partition at system generation time. So this static partition or fixed partition, maybe you can allocate in equal size partition, or unequal size partition. The static partition in the main memory can be done equally or unequally. Now let us see what are the pros and cons of this fixed partition. After that I'll take one example. The pros is it is simple to implement. The first advantage of using the fixed partition is simple to implement, and here the only little operating system overheads are there. Little operating system overhead. Why it's having only little operating system overhead? Because it is a static partitions. So you are allocating the memory statically. It is a fixed partition. So that partition may be equal or unequal. So we are not using the dynamic here. So it is a little OS overheads will be there, and cons will be inefficient. So the first thing is fixed partitioning is inefficient, like internal fragmentations, everything that occur in the fixed partition is inefficient. And here the maximum number of active process, maximum number of active process will be present, so that you call it as a fixed. So the process that are allocating the memory, that are the fixed partitions. So this is about the fixed partition. Now let us see what are the placement algorithm here we are using in fixed partition. Placement algorithm means how we are placing the process in the main memory. So you can use one process queue for partitioning per partition, or you can use a single queue. So the placement algorithm for the fixed partition can be done in main memory by using one process queue per partitioning, or you can go for a single queue. Instead of using the multiple queues, you can go for the single queue. So the single fixed partition can be done in main memory, means we are placing the process that you call it as a placement algorithm. You are placing the process by using the queue per partitioning or single queue per partitioning. So let me draw this diagram. What is it? Single queue and the multiple queue. Example, So let us take, so this is a main memory partitioning, main memory. So first here it is having the operating system. So the operating system is occupying the starting of the main memory, and here it is divided into, so I am talking about the fixed partitioning. So fixed equal size partitioning. First I am explaining about the equal size partitioning. So this you call it as equal size partitioning. Equal size partition. Now what about the unequal size partition? So the fixed partition is can be done in two types: fixed and equal size and unequal size. Unequal size means first the operating system. So you can allocate 8 megabytes, 2M, 6M, or you can go for again 8M, or you can go for 12M, like that. Okay, so this you call it as unequal size partition. Unequal size partition. So a fixed partition. So if you take 64 megabytes of memory, let us take, if you take the 64 megabytes of memory, the 64 megabytes of memory can be allocated like 888. So like that up to here. So equal size partition. Unequal size partition means you can take the divide the memory slots into unequal sizes, but it is fixed only. It won't be changed. Means one process can enter into only one slot, one chunk, one segment. So 8M, 2M, 6M, 8M, 12M, like that. Okay, this is unequal size fixed partition and equal size fixed partition. So let me explain about by using the placement algorithm. As said, the fixed partition can be done by using one process queue per partitioning or single queue per partitioning. So let me explain that. So let us take fixed partitioning placement algorithm. Placement algorithm. So here we are taking, suppose let us take a new process. A new process is divided into multiple queues, means the data is arranged in the queues. So like this. And here if you are taking the main memory, okay, so this is a main memory. First the operating system is stored, and each queue will occupies one slot, one segment. So this you call it as one process queue per partition. One process queue per partition. So for each partition, one process queue is arranging. So if you take a single queue, let me draw that also. New process. Okay. So what I am saying here, in the new process, you are taking only single queue. So this is a single queue. This single queue is occupying all the partitions. So this is single queue fixed partition placement algorithm, and this is one process queue per partition, one process queue per partition by using fixed placement algorithm. So this is about the fixed partitioning placement algorithms. Thank you.